Wales. The assessment said for this house here, there's a noise contour. There's a table for those that read, said different wind speeds, the highest it'll get to is 32 dBA. That's the prediction with all these turbines. Next. Okay, standing in the front yard of that very house. 5 o'clock, the background level was 30 dBA or about that. No wind, no turbines. A couple of hours later, standing in the same front yard, no wind, just turbine noise. It's a bit more than the 34 dBA that was predicted. And what I actually have that I've been using for a while is power output of the wind farm that actually tells me the wind farm was operating. So you get a trend that if you're in an isolated case, then the wind farm can give you the noise without the wind, but in an exposed location, which these three locations were, when the wind blows, boy does it blow. I mean, we had an anemometer at house 87 and we actually got a peak of 127 kilometres an hour. Our anemometer was still standing, so that was pretty good. So the problem is that there is an issue in the regression line and you can get measurements of it. So there's also a matter that you're trying to do a noise information as an LEQ, which is an energy average, and they put an increment of maybe 1.5 dB to the background levels. So you're not quite measuring it, but if the noise from the turbine changes around, it's got impulsive characteristics, it's low frequency, all of those need adjustments, but if you're not there, you're not hearing it, you're using dBA, you won't get the results. Next. 6, I think the last question answered it. Next one, 7. Okay, most people have got the questions anyway to keep up with me. This one asked for house 89. Next. Okay, in the preliminary stuff I had some frequency spectrums that showed in the consultative committee meetings about this. This is a sonogram again, and whilst it's a bit lower, we've still got these lines running through here which are not there between on and off. The interesting thing is that this house for this test is actually in a crosswind situation. That is, if this was a westerly blowing, so they won't be getting all the noise from the turbines, but they're getting some noise. Next. Okay, so what we actually have, same thing out of the previous graph. These are 10-minute averages. There are those lines that we saw standing out. By now, you've got an idea of wind turbine signature. And this is this interesting one at 31.5 hertz with the sidebands. And as I said, lots of people have been wondering about that. Next. Okay, this wasn't in the report. This is something new. Okay. Next. What we've actually done is, again, we've got a shutdown. And I started off to calculate the WTS. So the idea was take all the 10-minute averages, the LEQs, take out the data, find out the turbine signatures, get the numbers, plot them and work it all out. Very labour intensive. To do this graph took one of my guys 3 days to get the data out. We don't have it automatic. So we've got the same thing that you all know now, and you can tell me how the shut-off occurs, the anemometers keep going, and we get this result. The problem is that theoretically, in a WTS, it should go bang and bang because there's nothing there when the turbines are off. The problem we've got is that we reach the noise floor. I talked about noise floor in dBA. Well, all meters have a noise floor. And when we get to that noise floor, we actually can't measure anything below it. So what the correct way of expressing this is saying the WTS is somewhere below those dotted lines. And these are 2 bedrooms in house 87, one at the western end and one at the eastern end. Next. So what I've done is in a laboratory situation, you have differences between measurable levels and they'll say take 6 dB off. So I'm taking 6 dB off, saying it's somewhere below that, and you could actually take 10 dB off or more. But this is a thing for discussion and people to look at. Next. So put it in context, I tried again with the shutdown, and you're welcome to try to look at what goes on with the DBG is this dark green one. 0.8 hertz is the 1/3 octave of the blade pass frequency. We've got our LSL, which doesn't work. We've got dBA-LF, and you have trouble actually reliably saying whether the turbine's on or off. Now what is pretty good is when this thing jumps up, We get a big jump and it drops off a little bit here. We get a bit in the DBG, we get the bit that comes up with the 0.8 hertz, but then it falls back off again and we can't see. The DBA LF, well, it follows a little bit. When we started doing all this stuff and trying to correlate it, we found, as said in the report, we couldn't get any correlation with noise or vibration. What we did get is we got a really good correlation with a lot of those parameters versus the wind, not the wind output of the wind farm, because what we end up saying is we're actually in a lot of the parameters measuring the wind. Next question. Okay, I think I might have done this already, but we'll put it in here, and it's next because it's the same graph you saw before. 1/3 octaves don't show any difference, the FFT does. So I think I've answered that question, so that might be the quickest. Next one. Okay, as I said at the consultative committee meetings, and I did have up on the window a lot of the graphs. Not that many people went to look at them actually, I must have explained it correctly, but I had a room full of wall just plastered with all these graphs to stand back and look at it. The guys in my office thought I was mad, so I guess it proves it. But anyway, I went through this thing, let's go next, and we'll see how it went. This is what happened. We plotted these patterns, and we put the wind power, and we also had the wind speed, and we looked for the changes. And as I said, in the early stages, the residents were reporting changes. And actually, luckily for me, that was good, because I found out what was going on. When I came back to them and saw them individually, and said, "You're actually only writing down changes." They said, "Yeah, well, we only noticed the changes." And I said, no, I need to have this continuous. So therefore, the graphs later on have lots and lots and lots of arrows all the way through. Now that caused a lot of effort on these residents, which they have to be thanked for the incredible work that they did, because it keeps on going. And we know in South Australia a lot of them gave up because it just took so much out of them. But at least we had some methodology that was a bit better. Next. So what we did is that, I've already explained, we took the view on the hypothesis and we expanded these views, and we can only do it because we had the data. Nobody else can do this by looking at Paul Miskelly's website and getting the power output. It's not in the resolution that you need, and you don't get the wind information. Next. Okay, this is a touchy one. I showed earlier page 115, and this question does not actually represent what was on page 115. Now, the first part of the study, we found certain wind speeds that related to the high levels of disturbance. The brief was, relate certain sound levels and certain wind speeds with disturbances reported by the specific local residents. I've read it so many times that it's, I know what it's trying to say. Now, we did that. The second part required us to determine certain sound levels. Now, we tried all the DBAs, we tried the DBCs, the Zs, we tried the LSL, and all of those things just didn't work. So ultimately, when we got to the FFT, we could see the signal was there. By doing the on-off, we could prove that the signal was there. So what we weren't doing is, we weren't looking in the study about introducing something that was going to create a new impact. No, the study was looking at what was there and related to the disturbances. The disturbances were cited by the residents. Now, I've already said that sensation 5 was bad for them. So, what we did is we took 5 of them. Now, I said that if you had a drug trial, right, and if, say, 6 of those people got hospitalised or died, you'd be a bit worried about the drug trial. Now, we aren't looking for anybody to die or be hospitalised in terms of it, but the seriousness of having a point where people leave their homes, physically leave their homes or want to leave their homes, is a serious adverse impact. So if we can work out what the adverse impact is, then any criteria that can be done by other studies and looking at more data, that'll set the threshold level further down. Now, one of the things to be aware of for people that are writing some of these questions, when we deal with audible noise, the general concept is if you go up 10 dB for the same noise, it's subjectively twice as loud. And that's a general rule of thumb that people use for subjective loudness. When you get down to this infrasound region, the response of the ear changes, and it's not 10 dB, it's actually 5. So 5 dB difference in the dBWTS or any of these infrasound frequencies is a significant difference. But what we're saying is, and it's said in the report umpteen times, they could not hear the infrasound. Say that again. There's not one house that recorded above 85 dBg, so the infrasound that's there is inaudible. And we don't need to go on that red herring. So what we did is that if the WTS is there when the wind farm's operating, and it's not there when it's off, and we did the test an hour and a half, so I can't be criticised of mixing up the data and doing Friday versus Sunday, then we've got a pattern that allows us to tell what's going on. So the question that had back in there was, do you think the methodology was successfully passed through a peer review? The answer is yes, because there's some people that are actually worked in wind farms that have gone through the peer review and they've said, yes, they like it. I've got one very esteemed colleague in the UK who has said he loves dBWTS. He says it's the best thing that he's ever seen in looking at this problem. And I've got people in America that said yes to study. Now, it was designed to meet the requirements of residents and Pacific Hydro. And now, Pacific Hydro are getting some peer reviews. Well, I've got 2 professors and 4 PhDs reviewing it. And I've got some pretty good comments at the moment. I've already said that they said my vibration is a bit weak. That's okay. Give me more money and we can fix that up. Sensation 4 would have taken a long while. And as I told you earlier, the budget ran out and it would have been another 6 weeks of analysis to get to a point. We originally had hoped to have a bigger team as part of the project to look at some of this work, but we had a few problems with the contract and getting access to the site, and it cost me a lot in lawyers' fees to see what was going on. But there are others interested in it, and I've got requests from all around the world now to look at people wanting, now after the event, to come and look at it. 12, in figures 49, is just based on 6%. Well, again, I've said worst case scenario, and I've said, as stated in the report, more analysis is required. Next one. Well, in terms of 13, we've said, and I've said in the report, and Pacific Hydro and I've said earlier in the statement, we had restrictions. So to determine the second part was said, find certain sound levels that relate to the disturbances. The disturbances are what the residents gave me. We found certain sound levels and we went for sensation 5, and as I've said earlier, we expressed the limitations. In a socio-acoustic study, so for example, we had one of the biggest studies in Australia was in 1980 for the aircraft noise, which resulted in what's called the ANEF, Australian Noise Exposure Forecast. It was done by the National Acoustics Laboratory. At that time, they were the premier organisation for doing this work. Psychologists, acousticians, a lot of survey people, they asked all the questions, found out what was going on, they had noise levels, and they worked out noise levels that related to the percentage of people highly annoyed or highly disturbed. And that graph that goes up is called a dose-response curve. The National Acoustics Laboratory tried all sorts of different acoustic parameters to match with their data. And they finally came up with the ANF, which has a different weighting to the American system, and it relates to Australia. So you only get a small percentage, because most of the studies that you do and set the criteria by regulatory authorities is protecting 90% of the people 90% of the time. So if I've got a small sample in terms of the survey results, okay, I'm less than 10%. That's all right. Come down a bit from my work, and you're not too far away about where that 90 percentile, which is the top 10% people annoyed, come to. But I'm not doing the statistics, I'm just the noise guy. That's all I was doing, measuring the noise. 14, well, we've already done about that. Look, if we'd been able to do a research project, yeah, that's fine, but Pacific Hydro just didn't have the money. And I guess it's not their responsibility. Now, we, to enlighten us, I think we've understand the data. I've said about why Sensation 4 was not done, the amount of time. I think I've covered about the analysing of the data, but what we actually do in the WTS phase is we take the 10-minute wave files, we run them through our program called Reflex, we do an LEQ, we get the data that's there, then we manually took out all those frequencies, put them in the spreadsheet, worked them all out, we went through the observations that the residents gave to work out where their forward 5s and 2s were. Very, very labour intensive, and one guy's quit because of it, but anyway. We found the shape, we looked at the maximum power. There is a graph in there that shows when you change the power settings, how it works. Next. Correlation and trend. Okay. Correlation is a broad class of statistical relationships involving dependence. That is, they're useful because they can indicate what you can predict. Now, you compare a variable, say noise, versus the operation, say the power output of the wind farm. You look to different classes of mathematics to see where it could occur. Because the noise levels change with the power output of a wind farm, it's an extremely complex manner. And I did have one guy try and do the stuff, and as I said, we just couldn't get any correlation with the noise levels based on the residents' observations. We even tried with sensation and correlation. Well, we got somewhere up around about 0.65, but not really good. But when we do the wind versus the DVA or the linear level, we're up above 0.9, which is a real good correlation. But we don't want to know that we're getting a noise level versus the wind. We want to know what the noise level is versus the wind farm. So none of that worked. A trend line is used to go through the data points and see what the shape or the plot of it is. When you look at it, it fits in a pattern which is shown all the way around the world for people that have done the narrowband